Hey guys, sorry for the long 8 month break, but it's just 'cause I was going through school and I had to do so much. But we're finally back, and today we're gonna be talking about derivatives. So you guys might be wondering, what is a derivative? A derivative is it's like a slope of a tangent line at a certain point. And so first we're gonna be starting off learning a limit definition of the derivative. So here's my work here. So the certain function we're going to find the derivative of is f of x equals x squared. So we're going to find the derivative of x squared. So first we need to write out the limit definition. So this would be the limit as h approaches 0, and it's going to be f of x plus h minus f of x divided by h. This is f of x, and then h is the limit we're trying to find. So here I made a mistake. I wrote f accidentally here, so I just erased it. But this would be x. I wrote it down here actually better. X plus the limit of h approaching 0. You always have to write this here. You have to write this all the way until you take the limit, which is down here. But let's go back up here. X plus h squared minus x squared, which would be the f of x, divided by h. So then we're going to have to expand this. So we get the limit as h approaches 0 of x squared plus h squared plus 2hx minus x squared divided by h. We just expanded this. So then we want to find the limit as h approaches 0 of this up here. So we can just cancel out the x squared since we have a plus x squared minus s squared. So then here, limit of h approaching 0, we have h squared plus 2hx divided by h. We can factor out of h here. So we get h, we can factor out of h. So inside parentheses, we get 2x plus h. We get an h outside. So then we can cancel these two. So we can cancel the h in the denominator. So now we have the limit of h of 0, and then we have 2x plus h, and then we can just take the limit. So then we plug in 0 for h, so we get 2x plus 0, and then we know the derivative of x squared is 2x. So let's go to Desmos real quick. Let's see if this is true. So this is the derivative at the point 2 comma 4, and then it just so the derivative of this would be this. The derivative of x squared would be 2x, and then you can see they have a common point of 2, 4. But then as soon as it keeps getting bigger, the the function of 2x, its estimate for the tangent line gets smaller and smaller. So each one of these points gets they get a different, what's it called? They get believe my mind, they get a different derivative. So here we can get 2x squared. So then the derivative at 2x squared would be 4x, and then that would be the thing at 2x squared. But so that's for another day. But the derivative of x squared is 2x. So then you're wondering, can we take the derivative of this 2x here? And we can. It's just more of the same thing. So we have f of x equals 2x. Then we can find the derivative, which is written f prime of x. We get f prime of x equals 2 times x plus h minus 2x divided by h, limit of h approaching 0. Then we write the limit of h approaching 0. We just distribute the 2. So we get 2x plus 2h minus 2x divided by h. These two x's cancel. So we get limit h of 0, limit of h approaching 0, my apologies. We get 2h divided by h. We can factor out a h from the top. So we get limit of h approaching 0. And then we have an h on the outside. We have a 2 on the inside. We have an h in the denominator. These two cancel. And the derivative of 2x is 2. And then we can test that by putting it in Desmos. 22, actually. Y equals 2. Oh, it's not. Sorry about that. It's going to be y equals 2. And then You can see I slope in right there. So then, here I was trying to prove something, but it didn't work. So I put it here. We have f of x of c, c being any constant. So like you can have a constant of 1,000, 1, 5, 7, 15, any constant you could think about, you can have that. So I wrote the limit of h approaching 0, f of x plus h minus f of x. Then here you just get c minus c, which is 0. So we prove that any constant derivative is 0. So like if someone asks like what's the derivative of a million, it's going to be 0 still. So that was a quick like lesson on finding derivatives by limits. You can do any derivative you want in this limit, but there are easier ways to do derivatives. And then tomorrow, hopefully tomorrow, I can show you guys the power rule. It's simple. It's so simple. It can maybe take like 5 minutes of your time. So I could probably show you the power rule tomorrow, and then I could like show you the product, quotient, all the other rules later. So you guys can understand derivatives, and it can be much easier because calculus is not something that's like once you get calculus, you're gonna like calculus more than you like algebra. Like calculus is like super fun to do. So thank you guys for watching, and I'll see you next time.